What is mission engineering? How does it fit into the acquisition process? And what's the difference between mission engineering principles and what we're currently doing to develop today's warfighting capabilities? Mission engineering is the Department of Defense's mission-focused, decision-making approach to systems acquisition, data analytics, engineering developments, and lifecycle support from cradle to grave. Mission engineering introduces an expanded vision that leverages advanced technologies and tools to deliberately influence designs and investment strategy decisions to achieve desired warfighting mission effects. Mission engineering is not a new engineering approach, it is a communication and collaboration solution. It brings together best practices, users and stakeholders together early in the acquisition process, where the mission is quintessential towards creating the best product for the warfighter. Let's start here. Mission engineering focuses on the end user, the warfighter, and the missions they are tasked to perform. The warfighter is the consumer of whatever it is that industry produces to help them accomplish their missions. From the very genesis of an idea or need, mission engineering principles must be followed as prescribed in the Department of Defense's Mission Engineering Guide. As you understand these principles, you will see a heavy emphasis on spending more time up front asking questions, defining mission requirements, and developing measures of success with supporting metrics and credible data. You will also be introduced to a new paradigm of data visualization and virtualization that will aid decision-makers evaluating the technical efficacy of the mission for more informed investment strategies. In turn, the warfighter can begin work on the desired mission concept of operations with a well-vetted metrics, architectural artifacts, data sources, and requirements, all without losing sight of the mission focus. This is where well-established systems engineering and acquisition processes take the baton and continue the race to create desired capabilities throughout the design, build, test, and deploy stages of the mission engineering framework. As you work through the systems engineering phase following digital engineering tenets when appropriate, you will also have the latitude to implement best practices like agile development, model-based systems engineering, design thinking, and threat mitigation strategies. You may pursue design modifications through rapid prototyping, both physically and virtually, where you will have iteratively designed, tested, redesigned and proven your system before manufacturing decisions are made. When it's time to produce the capability, following mission engineering processes will enable you to once again make more informed manufacturing, acquisition, and production decisions. You will have stabilized the requirements and architectures, identified the metrics and data needs, modeled, prototyped, and corrected design errors, and you are now ready to produce the mission capability with minimal risk. Pursuing a process that's tied to the preceding mission engineering rigor, minimizing risk, and use of best practices, manufacturing success is assured. Training the warfighter is central to a successful acquisition and fielding of a mission-engineered system. In fact, from the onset, a mission focus opens designers and users to the full spectrum of world-class, high-tech training possibilities, from in-person training programs and full-motion simulators to immersive virtualization and beyond. What was only imagined yesterday is in the realm of the possible today. Once fielded, maintenance, logistics and sustainment capabilities are integral to long-term readiness and performance metrics determined in the early stages of this process and not as an afterthought. Both consumer and users of the system are involved in the process from the get-go as they should be. As the system operates successfully, risks and metrics determined in the beginning of the process continue to track any decline in performance or operational readiness, and the necessity to extend its service life, repair the system, or upgrade the existing capability are monitored, considered, planned, and budgeted for. When the metrics indicate it's time to consider a new capability or system, retirement, replacement, and transition planning begin. And the cycle repeats itself again. The work done up front to articulate the requirement, study it, bound it, understand it, and create a set of measures keeping the end user and mission in mind, ensures an optimum solution.